Okay, this is Module 5, Lesson 11, and this is the math video for Monday, March 30th. And our learning objective today is I will be able to show equivalence of fractions using multiplication, division, tape diagrams, and the number line. So up until today, we've been using area models to show fraction equivalence. And today what we're going to work on is basically the same thing, but instead of area models, we're going to use tape diagrams and number lines. So I'm going to switch to problem set 11. And this is on page 51 of your math book, if you have it. And I'm going to take a look at the directions for problem number 1. And it says, label each number line with the fractions shown on the tape diagram. Circle the fraction that labels the point on the number line that also names the shaded part of the tape diagram. So for A, I see a tape diagram, and then I see a number line below it. And what I like to look at is for A, B, and C, what's cool is the tape diagram for each of these, A, B, and C, is all representing one whole. But you'll see that they're decomposed into different fractional units. Okay, so let's look at A. And I'm going to look just at the tape diagram to start. And I see that, let's see, how is it decomposed? Well, it's decomposed into 1, 2, 3, 4 parts. And the part that's shaded is one of those 4 parts. So that's 1/4. So now I need to go down and actually label my number line according to those parts. So here's my number line, and I see that where I start is really at 0 here, and we're going to call that 0/4 since I'm divided into 4 equal units. And then my first hash mark would be 1/4. My second hash mark would be 2/4, 3/4, and my final hash mark at the very end of my tape diagram is 4/4, which we know is the same as 1/2, so that equals 1. Okay, now it says circle the fraction that labels the point on the number line that also names the shaded part of the fraction, shaded part of the tape diagram. So in other words, where is my shaded part meeting up with my number line? When I can see that my shaded part is ending here, so my shaded part represents 1/4. Okay, so similarly in B, I'm going to take a look at my tape diagram, and again, it's all in, it's divided one whole into equal parts, so I have to count how many equal parts there are. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. So this is eighths, so I have to label my number line in eighths. So I'm going to start at 0/8, right, because I have no parts there. I'm going to go 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then finally here I am at 8/8, which again also equals 1. 8 over 8 equals 1, just like 4 over 4 equals 1. And we'll get down here in a minute, and that's 12. 12 over 12 also equals 1. So I'm going to look at my shaded part and see where it matches my number line down here. And I can see here my shaded 2/8 here equals 2/8 on my number line. And what's cool is we're starting to see some equivalencies here. Since these all equal 1 and they're the same distance, I can see that 1/4 is the same as 2/8. Okay, moving down to C. And I kind of gave this one away already. I'd already counted these. These are 12ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my tape diagram is divided into 12 equal parts. So I can go ahead and label my number line the same way. I'm going to start with 0/12 here at the very end. Right, and I'm going to end up over here at 12/12. And let's go ahead and fill in all of our 12ths. So that's 1/12. 2/12, and I have to write kind of small because these are tiny little units. 6/12, 7/12, 8/12, 9/12, 10/12, 11/12, and then there's my 12/12, which again equals 1. Okay. Now I can look at my shaded part and see where does that hit in my number line. Well, sure, there it is at 3/12. So 3/12 is the same as 2/8, which is the same as 1/4. Okay, which we need to know for the next problem. If you turn the page to the next problem, it's going to refer you back to those number 1, A, B, and C problems. So let's take a look at number 2. It says, write number sentences using multiplication to show the fraction represented in 1A is equivalent to the fraction represented in 1B. So 1A and 1B, well, that's back here on this page. So I have to show the equivalency of 1A, 1/4, to 1B, which is 2/8. And thinking back to what we learned in previous lessons, I can use multiplication to show that 1A, 1/4 times blank over blank gives me 2/8. Well, what times 1 gives me 2? 1 times what gives me 2? Well, 1 times 2 gives me 2, and then 4 times what gives me 8? Well, 4 times 2 gives me 8. So 1/4 times 2/2 equals 2/8. One problem I've noticed some students doing is this: 1/4 times 2 equals 2/8. That's incorrect, because when you're saying 2, you're saying 1/4 times 2 really over 1 gives you 2/8, and that's incorrect. It does not give you 2/8, that gives you 2/4, which is incorrect. It must be 2/2. Right? 2/2 gives you 2/8. Okay, now let's look at B. The fraction represented in 1A is equivalent to the fraction represented in 1C. All right, so again, I have to go back to my previous page. My 1A is 1/4, and my 1C is 3/12. So I got to use multiplication to show that equivalency. Same thing, right? So 1/4 times blank over blank gives me 3/12. So I'm thinking in my head, what can I multiply 1 by to get 3? Well, 1 times 3 is 3. And then I'm thinking in my head, 4 times what gives me 12? Well, 4 times 3 gives me 12. So 1/4 times 3/3 gives me 3/12. Number 3 is very similar to problem 1, so I'm going to let you do that on your own. I do want to do one of the example problems on number 4, which says basically the same thing, but write number sentences using division to show. So you're going to complete number 3 here, and instead of using multiplication, you're going to use division, okay, to solve these two, okay? And then number 5 is kind of a little bit different a problem, so I thought I would do this example problem. It says partition a number line from 0 to 1 in fifths. Decompose 2/5 into 4 equal lengths. Okay, so I got to draw a number line and partition the whole into fifths. So I'm going to start at 0 fifths. I'm going to end up at 1 or 5/5. Right, so this is 0 all the way to 1 and a fifth. So 5/5, 0/5 to 5/5. So in order to decompose a number line into fifths, I have to draw 4 hash marks, right? 4 equally spaced hash marks. 1, 2, 3, 4. That's kind of equal. 1, 2, 3, 5/5, right? So now I can label 1/5, 2/5, 3/5, 4/5, and 5/5. Now, it says, write a number sentence using multiplication to show what fraction represented on the number line is equal to 2/5. Okay. Oh, sorry, I forgot this part. Decompose 2/5 into 4 equal lengths. Okay, so I'm going to start at my 2/5. So now I have to decompose this from here to here into 4 equal lengths. Well, that's easy. It's in 2 equal lengths now, so if I divide my 2 equal lengths into 2, now I have 4 equal lengths. And we just turned our fifths into tenths. So instead of tenths or fifths, we have tenths. So I can actually decompose all these guys. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10. So now I'm showing that 2/5 from here to here is the same as 4/10. So 2/5 equals 4/10. So what I can do now down here, it says write a number sentence using multiplication to show what fraction represented on the number line is equal to 2/5. Well, I already showed that up here, so I'm just going to show this in a number sentence using multiplication. So 2/5 times blank over blank gives me 4/10. What times 2 gives me 4? Well, 2 times 2 gives me 4. 5 times what gives me 10? Well, 5 times 2 gives me 10. So 2/5 times 2 over 2 gives me 4/10. Okay, and then down here it's asking write a number sentence using division to show what fraction represented on the number line is equal to 2/5. So basically what you're doing is you're going from 4/10 now divided by blank over blank gives me 2/5. Right? So 4 divided by something gives me 2. 4 divided by 2 gives me 2. And 10 divided by something gives me 5. 10 divided by 2 gives me 5. 4/10 divided by 2 over 2 gives me 2/5. Okay, and that's it for lesson 11.